Today I am going to explain about entropy. As we know that second law of thermodynamics, also called law of degradation of energy or law of entropy. The increase in entropy is small when heat is added at a high temperature, and entropy is greater when heat addition is made at a lower temperature. Let's take an example of a boiling water. When heat is added to a system at a high temperature, the molecules in the system are already moving quickly and randomly. Adding more heat doesn't make them move more faster or more randomly. So the entropy of the system doesn't increase by much. But in this case, when heat is added to a system at low temperature, the molecules in the system are moving very slowly and orderly. Adding heat makes them move more faster and more randomly. So the entropy of the system increases by a lot. Adding heat to a system increases its entropy, but the amount of entropy increase depends on the temperature at which the heat is added. So here in this image, an ordered system has low entropy, while a disordered system has a high entropy. So while moving from left to right, entropy increases and disordered increases. So this is how refrigerator works. A refrigerator takes heat from the inside of the fridge, which is a low temperature system, and transfer it to the outside of the fridge, which is a high temperature system. This increases the entropy of the outside of the fridge and decreases the entropy of the inside of the fridge, making the inside of the fridge colder. Entropy always denoted with S. Its symbol is the capital letter S and its units are joules per Kelvin. High S value means high degree of disorder in a system. It is the function of degree of disorder in the system. Entropy tends to increase means a change to a more disordered state at a molecular level. Entropy is a measure of the randomness or disorder of a system. If more disordered state, more entropy. If less disordered state, less entropy. Change in entropy can have positive or negative value. If it is positive, more disordered. If it is negative, then less disordered. Entropy is the measure of the disorder of a system. Entropy is an extensive property of a thermodynamic system, which means it depends on the amount of matter that it is present. So here is the equation for entropy, where Q is the heat that transfers energy during a process, and T is the absolute temperature at which the process takes place. Q is positive for energy transferred into the system by heat, and Q is negative for heat energy transferred out of the system. Dissolving increases entropy. For example, stirring sugar into coffee, it increases the energy of the system as the sugar molecules become less organized. Entropy and second law of thermodynamics. The second law of thermodynamics states that the total entropy of a system either increases or remains constant in any spontaneous process, but it never decreases. Entropy of one system can be decreased by raising entropy of another system. For example, freezing liquid water into ice decreases the entropy of the water, but the entropy of the surroundings increase as the phase change releases energy as heat. There is no violation of the second law of thermodynamics because the matter is not in a closed system. When the entropy of the system decreases, the entropy of the environment increases. So that's all for today. Thank you.